guys, welcome back to the new playlist of data engineering mastery. This is a new playlist where the oldest one was about mathematics of thinking, where we discussed about algorithms and maths. Within this new playlist, we'll be talking about real production pipelines, real problems, real fixes, real failures. And by the way, I am launching a Python formation. If you wanna subscribe, you can fill in the form within the description. And without further ado, let's get started. Episode 1: Why most data pipelines fall in production. If you have been a data engineer for more than 6 months, you have already experienced at least one of the failures that I am about to describe. If you have been doing this for a few years, you have probably experienced all of them. Today I'm going to show you the 6 root causes that kill the data pipelines in production and give you production grade Python code to fix each one. So let me start with a story you probably recognize. You build a pipeline, it works perfectly in dev, all your unit tests pass, your local run processes like 10,000 rows in 3 seconds, you push to production. 2 weeks later, your data analyst comes to you and says the revenue numbers look wrong for the last 2 weeks. You check the logs, the pipeline succeeded every single time, no errors, no warnings, just wrong data, silently delivered. Okay, so this is not an edge case, this is the norm. So the card one here, it works on my laptop. Your dev environment has clean data, small volumes, and no upstream dependencies. Production has none of that. So the pipeline that works on 10,000 rows silently corrupts data at 10 million. The card 2, the schema changed overnight. An upstream team renamed the column, changed the type from int to string, added a null field. Your pipeline has no idea to crash at 3 a.m. or worse, it does not crash at all and just produces non-values. Card 3, the job ran twice, a timeout caused the orchestrator to retry. Now the same job ran twice, you have double counted revenue. Your CEO calls you at 9 a.m. asking why the quarter 3 is up to 200%. In this episode, the 6 root causes behind all of this and code you can ship today to fix them. After working on data pipelines at scale and after reading post-mortem for teams who lost data, lost money, and lost trust, every production failure traces back to one of these 6. Root cause 1, no schema validation. You trust that the upstream data will always match what you expect. It will not. Root cause 2, non-idempotent jobs. Running in the same job twice gives a different result. In a world of retries, timeouts, and manual reruns, this is fatal. 3, silent data loss. Your except block catches the error and returns none. The bad row disappears, no log, no alert, no metric, 5% of your data just vanished and nobody knows. Row 4, no monitoring, the pipeline succeeds, status green, but the output has 2 million fewer rows than yesterday, so nobody notices. Hard-coded 5, the rows number 5, hard-coded configuration, database credentials, output paths, API keys, all in the code, so you push to GitHub and accidentally publish your production password. And 6, no backfill strategy, so you find a bug that corrupted 13 days of data, but your pipeline has no way to reprocess historical dates, so you have to manually fix 13 days of broken data. Let me go through each one and show you the fix, okay? So for schema validation, so schema failure are responsible for the majority of silent corruption issues I have seen. Look at the left panel, the fragile pattern. The pipeline takes a data frame, computes revenue as amount times tax rate, and groups by user ID. This works great in dev, but in production, if the upstream team renames user ID to user ID, the K error, silent crash, if amount becomes nullable, none propagates into every revenue calculation, if the type changes from float to string, type error at runtime, if extra columns are added, memory bloat on every run. Now look at the right panel, the fix using Pandora. We define the schema upfront. User ID must be a non-null string, amount must be non-null positive float, tax rate must be a float between 0 and 1. Then the very first thing our process function does is call the schema validates the DF, the data frame we created. If anything is wrong, it raises a schema error with a clear message before a single row of bad data is written anywhere. This is the principle of failing loud at the front door. You want your pipeline to scream on ingestion rather than quietly corrupt data in the output. So Pandora is my library of choice for data frames. Great Expectations is the alternative for more complex data quality rules. Pick one, but use something, okay? Second, we have the idempotency. So the bug here is the most expensive failure in data engineering. It does not crash the pipeline, it duplicates your data, and by the time you notice, you have delivered wrong numbers to every downstream consumer. The definition f for f to x equals to f to x, applying the operation multiple times produces the same result as applying it once. In data engineering terms, if your pipeline runs twice for the same dates, the output should be identical to running at once, okay? So look at the bad pattern on the left. If exists equals append, this is the most dangerous line in data engineering. It appends on every run. I mean, if you run it twice, you have twice the rows. Run it 10 times, you have 10 times the rows. So the orchestrator retires after a timeout. You have duplicates, no crash, just wrong data, duplications. So the fix on the right here is to delete the partition, then insert wrapped in a transaction, so it's atomic. First delete from cells where date equals the execution date, then insert the new record, run it 10 times, the same result every time. The transaction is critical. Without it, the insert fails after the delete. You have an empty partition with the transaction. It's all or nothing. So note here, on most modern warehouse, BigQuery, Snowflake, Databricks, you would use merge or insert overwrite for the partition instead. Same principle here, always overwrite, never append. For the root cause 3 and 4, the silent errors and monitoring, these two root causes go together. So because they are two sides, of the same problem. So root cause 3, silent errors, looks at the left panel. The pattern is everywhere. A bare try except that returns none or on any error. The intent is to make the pipeline resilient. The effect is to make it silently broken. What actually happens here in production, the pipeline runs status success, but 5% of your row had a missing field and were silently dropped. So your revenue report is 5% lower than reality. You find out that 2 weeks later, when the business team reconciles with finance, the rule here is never swallow an exception without a log account and a threshold. Look at the right panel, the production monitoring pattern, a pipeline metric, data class tracks for numbers, rows in row out, row errored and row dropped. Every time a row fails, we increment row error and log the specific error. At the end of every run, we call validate run, which checks the drop rate against a configurable threshold. If more than 1% of the rows fail, we raise and abort. So this means that the pipeline now fails loudly when data quality degrades instead of silently accepting corrupted output. The root cause 4, which is non-monitoring, this is about monitoring the output. not just the execution. Success status means the pipeline run. It does not mean the output is correct. So you need assertion, expected row count is within 10% of yesterday, null rate on k columns is below 2%, revenue total is within the expected range, etc, etc, etc. Then for the two remaining code rows, the config and the backfill, the rows cause 5 hard-coded configuration. So look at the left panel. You have seen this everywhere. The DB host hard-coded in Python file API key as a string literal output path backed into the script. 3 failure modes. 1, you accidentally commit credential to the version control. 2, you cannot deploy to a different environment without editing the code. 3, the config changes require a code deployment, not just a config update. So the fix uses PyDownTech settings. So you define a setting class that inherits from base settings. Every setting is typed, every setting has a name, and the class reads from the .env file automatically, so different environments get different .env files. 0 credentials every touch the code base. The fix is simple but requires designing it up front. Every pipeline must accept an execution date parameter. The extract, transform, and load must be all parameterized by the days, and the job must be idempotent because backfill means running it again. So the right panel here shows the pattern. A date range generator yields every date between start and end. Run pipelines accepts an execution date to backfill the entire month of January, a single for loop. So this is also how Airflow works under the hood. Every DAG run has an execution date. Every task should be parameterized by it. So let me put it all together as a single architecture. So 5 stages, each one mapped directly to a root cause fix. The extract parameterized by date, this solves the root cause fix. Your execution knows which partition to pull. Pass the execution date, never hard code today. Validate schema and null checks, this solves the root cause 1. Pandora validates before transform bad rows are either rejected loudly or quarantined. Transform error tracking per row, this solves the root cause tree. Pipeline metrics tracks every failure. Threshold enforced before anything is written. Then we have the load, it deletes, inserts, idempotent. This solves the root cause to delete the partition. This inserts, then insert save to retry, save to backfill. We have the assert row counts and data quality. This solves the root cause 4. Compare output row count to expectations. It check null rates if assertion fail. Alert before downstream. Consumers rate the data. And root cause 5 is solved at the infrastructure level. Every connection string, password, and configuration value reads from the environment via PyDownTech settings. And together these 5 stages from a pipeline that fails loud at every layer and never fails silently anywhere. So the production checklist, this is the checklist I run before every pipeline goes to production. 6 questions. If any answer is no, the pipeline is not ready. So the question 1, is the input schema validated? If is the job idempotent, are the errors logged and counted? The output quality monitored? Are credentials in the environment variables? Can you backfill historical data? So you can save this checklist, add it to your team's PR template, review it before every production deploy. So 4 things to take away from this episode. 1, validate the schema at the front door. Use Pandora, fail loudly or on the ingestion. Never silently in the middle of the transform. 2, make every job idempotent. Delete the partition, then insert running the same job twice should produce identical output, not double data. 3, track every failed row. Never swallow exceptions. Log count and threshold your error rates. A pipeline that silently drops 5% of row is broken, even if the status is green. 4, monitor the output, not just the execution. Row counts, assertion, null rate checks, and value range validation are part of the production ready pipeline. In the next episode, we'll build a full production ETL pipeline from a REST API through Azure Data Factory into a Delta table, wiring up all 6 of these patterns into a real deployments. So drop a like if this was useful and tell me in the comments which of these 6 rows causes have you hit in production. The silent data loss one, I guarantee most of you have doing it. So see you in episode 2.